recording first and then do share screen. Let me bring the website. Okay. Okay, here it is. Okay, if you recall, yesterday we already started about secure coding. So we started with Rule 5, object orientation. Today we start with number 4. Okay, it's providing mutable classes with copy functionality. Okay, to safely allow passing instance to untrusted code. So let's see this first example. Maybe you're already quite familiar with this concept, if you recall, because previously, I remember even in our exam, we kind of have this kind of deep copy concept. Okay, so for this class is that it's a final class. And who remembers what a final class means? What's the difference between a final class and a non-final class? So final class versus non-final class. Who still remembers the difference? If a class you have this keyword final, that means what? Means it can, you cannot do what? Cannot be extended. Okay, for subclass. So it cannot be superclass. Okay, so keep this in mind. Non-final one, then you can use it, use inheritance to create a subclass. Okay, so make sure this difference. Okay, and so here we have the data member instance variable date, is it? And this type is what? It's a reference type. Reference type, is it? And then for the accessor, and if you directly do return date, anyone still remembers? Is this good? This violates what? Who remembers?
We need to copy before returning the date.
Yeah, very good too. Yeah, okay. Because think about this, you make it private, is it? The private visibility, accessibility, the purpose is to what? To encapsulation. But then here, your accessor expose it, is it? So you violate. Hold on. Admit. Oh, okay. So basically here, then it's violate encapsulation. Is it? So that's not recommended. Okay. So how do we fix it? Anyone remembers? But you do want to have the accessor. Is it? So generally speaking, normally, how do we fix it? Yeah, very good. You can do clone, is it? Make a deep copy. Is it? Deep copy is clone method. Is it? Okay, so keep this in mind. Okay, so we already learned this. So here it says some solution. Is it? Okay, solution, let's see. Over here, if you take a look. So over here, it copy, is it? But it's use clone, is it? To return it, okay? And here we cast it, because generally speaking, clone method return object, is it? Not to the specific date type, okay? Okay, so that's the solution. And let's take a look this example. It's going to be interesting, okay? So this is another solution because you do want to get that instance variables contents. Is it how do we find a solution? Is it? Okay, and here for this class commutable class, it has a date, is it? And be careful, here it says it's final, okay? And then this is a constructor, but this time you see the constructor is as private. This also kind of different from what we previously learned, is it? But constructor can be private. Okay, this is different from C++. C++ construct must be public, okay? But here constructor can be private. Then you may ask if a constructor is private, what's the point? Is it because you see here it's private, then you cannot instantiate. Is it? You cannot instantiate and you cannot subclassable. Okay, but anyway, this private constructor, what it does, so you pass in a date. Is it? So this argument is what? Is a reference type. Not a primitive type, it's a reference. Then you need to be careful, okay, when you do this assignment to your instance variable. Is it? Here you do what? You cannot just assign D. You said date equals D. Not accessible. Okay, you need to do what? You create a copy. Okay, so here that's why it says make a defensive copy. Okay, but have the same time. Is it? So on heap. Is it? So this is D. Is it? And you create a copy. Is it? With this new. That's a copy. Is it? But have the same time. Is it? But it's an independent one. Okay, and this is going to be assigned to this date. Is it? That's what you need to do. Okay, be careful. And then for the get, it's similar. Is it? We create a deep copy using clone. And then let's take a look at this method. Here it says get instance method. And this get instance, the parameter is what? Is the class itself. Is it? The parameter type. And its return what? It's also the class type. And the method is what? Is a static method. Okay, so here is our first quiz question. Okay, first quiz question, static method. So what's the difference between static method versus instance method? Who still remembers this? And
static
here
is immutable.
Static is
Can't change.
No.
Isn't it that only class can use it?
Yeah. Static method means what? Okay, so here we have some. Static is a class method. Okay. It's a class, it's not an instance method. So here you see instance method. The keyword is instance. So you must have an object to use it. Is it? And static, no object needed. Is it? So that means for this method, when you use it, you can do this. Mutable class dot get instance. Is it something you can call like this? And for this get date, you must do what? You must do mutable class. Suppose variable equals new. So over here, there is the issue. We cannot call new mutable class some date. Is it? Well, I shouldn't use this. I just use D. Can I do that? Can I do that like in this case? I cannot. This is wrong. Is it? You cannot do this. Okay, you cannot do this. So here, if you do want to have an instance, then in this case, what you can do is you need to call this method instead. Okay, so it's very tricky here. Okay, it's very tricky here. Because why you can do that? Because this guy returns. This guy returns an instance. Is it? What is this? It's called private constructor. Okay, this call this private constructor. Okay, and you may ask why don't just give why just don't give a public one? Is it because then in this case you can only create this single instance? Is it? You can create a single instance. Okay, and this generally also, this method basically to create objects. Is it? This kind of thing. Basically, it's a design pattern. Okay, so it's very advanced knowledge about programming. So this generally we call it public static factory method. A factory method is regarding how to create objects. It's a factory. Okay, so that's the idea. So here, this is new, is that constructor, you can make it private. And then in this case, generally, when we do software development, the design is then you can have this kind of static factory method. Okay, and you let it call that private constructor to return some instance. Okay, so that's another way. Here it provides some other solutions that we can also achieve the goal. So for this class, it's final class, is it? And it implements clonable. Okay, and its constructor is still public. And for this get date, you return the clone. And for this method, what does it create the clone method, is it? And within the clone method, what it does, it first call superclass clone, is it? But then it also specifically clone date, okay? And then return it, okay? If I cross this out, will this clone be a deep copy? No, then this is a shallow copy. Shallow copy, okay? Because this super.clone cannot provide you a deep copy, is it? Because this class instance variable is a reference type. And if it is a reference type, then you must explicitly make another deep copy. Another deep copy, like over here, what we did. This part, Okay, you must do this. Okay, otherwise not a real deep copy, even though you say, oh, I implemented the clone method. Is it why then when you debug your program, you may say, oh, why it's mess up? Is it that's the reason. Okay, so be very careful. Okay.
Oh, can I ask a question?
Yeah, please.
How is just a public class different from public final class?
Oh, yeah, very good question. Okay, you probably missed that. Okay, let's do, this is our second quiz question. Second quiz question. Okay, so difference between final class versus non-final class. Who remembers what we discussed at the beginning of class? Who still remembers the difference? If this mutable class defined as final versus no final.
Final class cannot be extended to create, cannot use as a superclass.
Mm-hmm.
Yeah.
Very good, very good. Yeah. How about non-final class?
Non-final class can be extended,
Yeah.
can use as a superclass.
Yeah, very good. Okay, so that's the answer. So everybody got it? So keep this in mind, okay? It's very useful. Yeah,
just to
please.
clarify, so mutable class cannot be a superclass?
Yeah, in this case.
Okay.
Okay, so this specific class cannot be superclass. Okay, so that's a difference. Okay, that's a major difference. Very good question. Okay, let's see any other solution. Okay, here it says what we can do. Okay, same thing. It's still a final class, is it? And what's okay? So here it also implement the clone method, is it? So it has the date cloned, and then what this time it did is it call the constructor itself, is it to create a new object and return it, okay? So anyway, this is also an option if you want to comply it. Okay, very nice. Let's see this option. So over here, there is another option. Sometimes you may not be able to do something on the object itself, is it? Then what over here is you provide, be careful, okay, it says unmodifiable date wrapper. Okay, date wrapper, what does this mean? So it's just a view. So that's why the class name, we said, okay, unmodified date view. Because whenever you see view, you cannot modify, is it? You just see it, is it? You cannot change it. And it extend date, okay, data class. So the data member instance variable, it's still date, is it? And this is its constructor, okay? So it just, so here you may question, why here you directly assign? Is it that's kind of violate to what we usually do? Is it this is a reference type? Reference type. So does this violate our regular rules that don't directly assign? You assign a deep copy, is it? This is fine, okay? Let's see. Because why? For this set class, set method, is it? For this set method, then you cannot do anything. So basically this class, that's why we said this class is a view class, is it? Because it doesn't allow set. As it is said, if you want to do any set, it will throw this exception, okay? So that is this class, okay? So this class only allow you to view, okay? Won't allow you to access. Okay, and then this mutable class, that's our user class. Then for its get date this time, you return what? you return that modifiable view class. Is it? Then you just return that instance. Yeah, this is fine. Is it? Because what you get is that a modifiable view. Is it? And on that, you cannot change the date. So this is also doable. Okay, that just shows us different options. Okay. Okay, that's regarding this rule. Then let's move on to the next rule. Next rule has some similarities, okay, between as what we discussed before. Is that do not return reference, okay, to private mutable class members. Okay, let's see the first example. So similar, this mutable class. What here you just return. Is it? So this violates what we just discussed. And what the solution is, you copy. Is it to make a deeper copy of that? You return the clone. Okay, and then for this one, this time, this mutable class, is it? It's an array. So instance variable is an array, okay, and okay, the constructor pretty straightforward. And for this get method, it returns an array. So it just return date, or it says return date.clone. So is this compliable? Is this a good design? So this is the third question, quiz question. Is this a good? You say, mail, oh, I returned the clone. Is it? So is this going to be good design?
No.
Yeah, okay. Yeah, because it's a red box. Is it here? What you need to do? Let's
Because
see.
it's red box. Okay.
Yeah. No, this is a compliant solution. Okay. So this is array, is it? And if you recall, array in Java is a reference type. Is a reference type. So you cannot do that, is it? But you do want to return the array, is it? How do we do it? You need to do new date. Okay, you need to do this. You need to create a new array. Okay, and this is also complicated, is it? Then for each of the array element, for each array element, make another deep copy. So this is kind of two-level deep copy. Okay, array itself, you need to make a deep copy. How do we make a deep copy? You can do create new. Is it? This always make sure you create a deep copy. And for each element, okay, you also need to create a deep copy. Okay, so be careful. Okay, so that's for this solution. And the next, let's see. Okay, so red box means the code has problem. Okay, so anyway, this is an instance variable. Don't worry, okay, so anyway, so this is some kind of collection data structure. This is called hash table, okay? So anyway, just like a linked list, array list, what we learned before, is it? So anyway, so this is also reference type, of course. Instance variable, is it? And what over here, you said, oh, get value, is it? Get value, then you return this hash table itself, is it? So you return object. That's violate what we learned, is it? You cannot do this, is it? Because over here it says entrusted caller, is it? And then can do some bad thing, is it? So that's not a good design here, okay? A solution to that is the same thing. You need to make a copy, is it? Okay, but here, okay, so here it says this is not a red box anymore, is it? It's purple, so it's compliant. So this is compliant, is it? But if you recall the collections, the clone method, it's a shallow copy. Okay, it's not a deep copy, but this time it works. Why? Because anyway, for this hash table data structure, the type is immutable reference type. Then if you just call clone, that is fine. That is fine. Okay, so this is going to be a deep copy of your collection. Okay, so no issue. But you see, if over here I change it to account, then this is going to have issue. Okay, this is just like what that mutable class. Okay, the array. Then because the second level is it for the account, that still not have a deep copy. Okay, have a deep copy. Okay, so that's, but in this case, this works. Okay, and if you try to understand from the heap, is it? So this is that HT, is it? The clone. So if you call the dot clone, it's going to create a copy. Is it create a copy? The difference between integer and string is, in this case, it works. It just have its own copy, okay? But if you have an employee, is it? So this employee basically is pointed to somewhere else here. Here is the employee. Okay, if you don't do another copy, then this also point to here. So that's a shallow copy. Because both point to the same person, is it? So if you really want to achieve the true deep copy, what you need to do is you need to also make a copy of the person, is it? And then make it point to this. Then that's a real deep copy. This is deep copy. Okay, so that's a difference. Okay, be careful when you have array and the collection. Okay. Okay, so that's this one. Next, let's see. This one. Okay, the this one is defensive copy mutable inputs and mutable internal components. Okay, what all of this means. So first, let's take a look at this example. So here we have some class, is it? And this class is a final class. And over here we have a method called use mutable input. Okay, and this use mutable input's parameter is HTTP cookie type. Okay, so if you're a web developer using Java as a backend, you will see this a lot. Okay, so anyway, so this is a reference type. Again, we learned, is it? And what this method does is, oh, if it's not, if it's null, you throw null pointer exception, is it? And then here, okay, you check if it's expired, is it? Okay, if it's not expired, then you continue, do something on that cookie. Is it on that cookie? And you may say, oh, it didn't see any issue. Is it looks like it's okay? But be careful, is it? Because you work everything on this cookie. Is it? This cookie is some objects on heap somewhere. Is it? So you directly work on something on it. Okay. Okay, but there is some potential issue. Okay, potential issue is you may check here. Okay, so pass the check. Pass the check. Is it? But you see, because this is a cookie over the internet application, and between this checking and this do logic, there may be some time. Is it? Maybe you have 15 seconds or something. Is it? And then maybe some attacker do something on this cookie outside. Is it? And then but you still do logic cookie, do something on it. So that has some potential security exposed issue, is it? So that's not recommended. So the way you recommend is you create a copy, a deep copy first. Then everything you work is on the copy. Is it? Because attacker cannot see this. Okay. Cannot see the copy. Is it? Has no way to get the copy. Is it? So this part then is secured. Is it? Just think it deeply. Okay, after our class, you can study the code more, you will find. Okay, so that's one we showed. Is it? And here similar. Another method is it, and this time you have array also, is it? And you also have an array of the cookie, is an array of the cookie. Then if it's this case, similar, you better make a deep copy, is it? For the cookie, you also make a deep copy, and then you do something, okay? So always keep this in mind. Sometimes it may involve multiple level of deep copy, okay? You need to do, you do need to make sure, okay, it's okay. And here similar, is it? For this is because this is a reference type, and then you just do the clone. Is it? The clone here says the collection is an inter. Okay, so that's also not recommended. So what we recommend is, okay, you create an object. As you create an object with array list in this case, and then you call that method on this object. Okay, because this is interface. Okay, not an object. So the issue here is, because later on we will see other examples that may help you better understand, okay? Because it's an interface, okay, then an attacker can create a concrete class, and this concrete class implements this collection. Is it? Then in that case, this will have some issue. Okay, but for this case, then you won't have, because this object created by this specific array list. Okay. Later on, when we see another example that probably can help you understand better. Okay. Let's take a look at the next rule. The next sensitive class that must not let themselves be copied. Okay, what does this mean? So let's see. Okay, so this class, within this class, you have the file name and it's an array. So normally like a password or account information, is it, or your social security, those kind should be secured, as it should be secured. Okay, so then let's see. Looks like, okay, for this constructor, looks like no issue. And then over here, we have this method, as it called replace, then it can replace. And this get method, is it? And then this print method, okay. Okay, so all of this. And over here, another question. So this is a regular class, that, and here the method is a final method. So once again, so this is our, how many quiz questions we already have?
We've had 3.
3, so this is the 4th quiz question. Okay, so it's a final method versus non-final method. Who remember final method is what? Final method. Why here we define as final method?
Is it the final method cannot be override?
Yeah, very good, very good. Okay, excellent. Okay, so that's the answer. Okay, final method. So even though the class, you can create a subclass using this class, but this method in this class cannot be overridden. Okay, you cannot override it. Not like you remember toString method, is it? We always override it, is it? Okay. So anyway, so all this method are not overridable. Okay, so that's this class. And then let's see, this is over here. Okay, then here we have this class extends. We create a subclass. Is it? So this is a subclass. And this class extends from that sensitive and implements. Okay, and okay, so here is its constructor, nothing new. And here is its clone method. Is it clone method, clone called the superclass clone method? Is it? Okay, so looks like so far we didn't see any issue. Is it? And then let's see. Over here, our driver. Is it? Okay, driver, first we create a first, we call this malicious subclass. We create the first one with this specific file name. Okay, the second one, you clone with the first one. That's fine, looks fine. Is it? Okay, this S, you call ms1's get method. Okay, this get method will give you what? Let's see. This get method, we'll call this, is it? So it's going to return the file name as a string, is it? So it will call, so this will call superclasses. Classes get method. Get method, is it? Okay, then you print the file name, so nothing changed, is it? Okay, then you call ms2's replace, is it? You call ms2's replace, and ms2 is a clone. You may think it's safe. I didn't do anything on ms1, is it? I didn't do anything on ms1. So here is the tricky part. So a lot of times the attacker use the subclass to do attacking, okay? But here is a problem. Is it? It just do what? It just call superclasses clone, okay? And let's see. Superclass, superclass's instance variable is reference type. Is it? And this superclass doesn't have any clone. Is it? So its clone is from object class. Is it? So this clone basically is a shallow copy. Shallow copy. Is it? Okay, shallow copy. So over here, you call this clone. Is it? The S2. Is it? Okay, so basically, here is that string, the file name. File name. Is it? File name. So here is ms1. Is it? So ms1, it's instance variable. Is it? It's instance variable. It's going to anyway point to this one. Then for ms2, because you call the clone, is it? So anyways, oh, here we have that ms1 object. That object will point to. So this is the object. Okay, so that's a variable. Is it? So it's pointed here. And anyway, it's pointed to this. And then you have ms2. Is it? ms2 is a clone. Clone. Is it? You call that clone. Is it create a copy? But it's also pointed to this file name. So both point to this same file name. Is it point to see? That's why when you do this replace, basically this replace still working on this file name. So that's why you may see the printout later on. Your file name changed to, got to change it. Okay, so this is one kind of attacker. Okay, you use subclass. So if your superclass didn't design well, you have this security hole. Okay, so malicious attacker can create subclass to do this kind of attacking. Okay, so that's what this part try to mean. So the solution is what? Is you make your class final. So if you make your class final, it won't let you create a subclass. So a lot of cases in the real world, when you write application, when you do OOP design, you need to be careful, okay? If you want your class to be able to create a subclass, if you allow it to have subclass, okay? If not necessary, then always recommend make your class as a final class. Then it's very safe, okay, for this kind of subclass attacking. Or it says you can make your clone method final. That's it, and you won't allow it to do anything. Okay, so that's another strategy you can do. Okay, anyway, so this is this rule. Okay, then let's see, number 8. Number 8, do not expose a private member of outer class. Okay, so this involves inner class and outer class. Okay, so let's see. So here you have the coordinate class, and within it, you have this point class. So this is an inner class. We learned it as it before. So this is inner class and it's public. As it is public. And this inner class at point, it output the coordinates. Is it? So kind of already expose private instance variable. Is it? Okay, then like over here, okay, our main is that you create. Then you see, you can directly through the inner class, then you can get its point. Okay, so that's not something, think about it, is it? Because if over here is some password, if you design something like this, then your password get published everywhere. Okay? That's it. So you don't want that to happen. Okay. So what you need to do is when you have inner class, be careful. Okay. You need to determine if you really want to expose your inner class. So better make it private. Okay, so that's another rule. Then if you want to write some code like this, you will fail to compile. Okay, so that's number 8. Number 9, so compare class, not class name. Okay, so let's see. A lot of time is that you want to see, oh, if some class is some specific class that you want to determine in that case, because for any class, you have this default method, get class. Okay, you can always get the class definition. Okay, and if you want to compare with another instance, that don't do that get name. Don't use string comparison. Okay, you just do this get class to compare. Okay, so that's a recommended way. So like over here, it shows more. That so if you have some class, is you call get class, and here you say, oh, I can use string comparison. Is it? So do not use string for class name comparison. Okay, use get class instead. If you really want to make sure, okay, both instances are from the same class. Okay, let's see, number 10, okay. Number 10 says do not use public, static, non-final fields. Let's see if, I think let's skip this, okay, so this is not a, that next one is quite useful, okay, constructor. And here the constructor recommendation is when you in constructor, you try to throw exception. Okay, so this is not recommended. Like over here, it shows an example. So it says bank operation, is that your constructor? Then you may say, oh, you want to check a social security number. Then you throw some exception, is it perform check? And here you said the return false, is it? And you grade, okay. So that's what this constructor does, is it? And then next you have some class defined as storage, and here you will create a bank operation instance, a variable, is it? And then you have some method try to do something, okay? So anyway, so and that method try to, or that class constructor throw exception, is it? That's generally we don't recommend doing that. Okay, we don't recommend doing that. What we recommend is, because that may cause some issue if you create some subclass, okay? So compliant solution is, did you see it again? Okay, make your class as a final class so that we can avoid the subclass attacking. Okay, because when you allow subclass, you know, so like the other one we mentioned interface, is it as parameter that also has some this kind of issue, is it? So then one of the way to avoid it is you make your class final, okay? Then you can avoid this kind of trouble. And the other way it says you can also make your method is then not to be overridden, okay, not to be overridden. So this is another solution. Okay, so we kind of, let's see, the next rule is 12. 12, it's empty, okay. And the next issue reference to mutable, yeah, this is pretty similar, okay, if you take a look, because it's array, okay, array, try don't expose it. And the last one, it's empty, okay, nothing new. And rule 6, it's regarding all sorts of security rule with method, okay, and we don't have time to go over it, but if you are interested, I recommend you also read it, okay. And the rule 07, it's about some exceptional, okay, behavior, okay, so you can also read it. And the rule 8, visibility and atomic, some of the rules also we can understand it based on our class material, okay. And of the remainings, it's kind of more advanced right now for our class. So for security, so that's the general information, okay.